Hey, Algebra 2. This is just a little bit that we didn't finish when we did systems that I want to go over this week because there are a couple questions like this on the exam. As you know, you'll be reviewing for the Unit 3 exam this week. There's a review practice problem Schoology that I want you to do, okay? But I also wanted you to understand that we didn't really do any application problems last week. We just did the systems of equations and you understand what makes something a solution, etc. Let's look at one where we use a system of equations to solve a real life problem, such as this. You need to earn at least $92 this week, okay? You can't work more than 20 hours. Right? Due to whatever restrictions of your parents, of school, of an activity. 20 hours is all you have this week. You earn $7 per hour for walking dogs. You earn $5 per hour for washing cars. We want a system of equations that will satisfy this. Now, as you see, I already have it graphed over here, but let's think about the two different equations we have. We have the number of hours that we're allowed to work, and we have the money that we can earn, okay? We have the number of hours that we can walk a dog is different because we get $7 an hour for that, and we have the number of hours that we can wash a car. We only get $5 an hour for that. So first we have to pick some X's and Y's, okay? So I am choosing to let X represent the number of hours that I walk dogs total this week, okay? So maybe I walk Scout down the street for 2 hours and I walk Fluffy up the street for 1 hour. Then I know I've walked dogs for 3 hours this week. I'm letting X be the total number of hours that I walk dogs this week. And then I'm going to let Y be the total number of hours that I wash cars. Okay? So I'm going to let them represent. Now I know that I can't work more than 20 hours. I know I have to be less than 20 hours. In fact, I can't even equal 20. I can't work, or I can equal 20, I'm sorry, but I can't work more than 20. So when I add the number of hours I walk dogs, which is X, plus the number of hours that I walk, the number of hours I walk dogs, plus the number of hours I wash cars, that cannot add up to more than 20 when I add them together. The X plus the Y has to be less than or equal to 20. Now be careful. That's where that symbol is going to be tough, I think, figuring that out. A lot of times when people see the words more than, they think, oh, that's greater than. That's true. But this is saying I can't work more than 20. So that means I can work either less than or equal to 20. But I can't work more than 20. Okay, then let's talk about the money. I get $7 per hour walking dogs. I get $5 per hour washing cars. So since X was the number of hours walking dogs, I'm going to take 5 times that, and that'll be how much money I got. For example, if I did the 3 hours, 2 for Scout and 1 for Fluffy or whatever I said, that was 3 hours. 5 times 3, that would be $15 that I made walking dogs this week. Okay, it's $5. No, it's not. Oh, thanks. I heard you. You're right. Thanks for sharing. It's $7 for walking dogs. It's only $5 for washing cars. So $5 times the number of hours I washed cars. I have to earn at least 92. So think about that for a minute. Is that less than 92? What does that mean, at least $92? Does that mean I have to work that I want to earn less than 92, less than or equal to 92, greater than 92, greater than or equal to 92. What does it mean when I say at least $92? At least 92 means I have to make 92 or more. I'm not going to be upset if I make more, but I have to make at least 92. Guys, that's greater than or equal to 92, okay? And those are the lines that I have graphed over here, okay? X plus Y is less than or equal to 90. First, 20, geez. First, I'm gonna add X and Y, and it has to be less than or equal to 20. So I know it's gonna be, since it's less than or equal to, it's gonna be a solid line. And here it is, it's going through 20, a slope of -1. If I would rewrite this, I would have Y is less than or equal to -X plus 20. Okay, so that's this line. And think about it, all these points on this line add up to 20. What's that? 12 and 8. This point is 8, 12. That means I work 8 hours walking dogs, 12 hours washing cars. And that would add up to 92 exactly, right? Does that make sense? Okay. Or that would add up to 20 exactly. I'm sorry. That adds up to 20, and I have to be less than or equal to that. So I shaded everything under there. Now the other line, this one, if I would get it in slope-intercept form, less than or greater than or equal to -7x plus 92, and then I divide by 5. Y is greater than or equal to -7/5 x plus whatever 92 divided by 5 is. That's not going to go evenly, is it? It's 18.4. So if I look, here's 18.4. My slope is I went down 7/5. Okay, look, this is going by 2. So I probably would plot a couple points to get that one, to get a nice solid answer. And then it's everything above that because it's greater than or equal to. Okay, so we shaded this area, and these are the number of hours I can work. Anything in the shaded area. Okay, so let's look at the questions they're asking here. I made a mess of this. How many hours will you have to wash cars if you can't find a job walking dogs? In other words, 0 hours walking dogs. If I don't have any hours walking dogs, what did we say, 18.4? I'm going to have to wash cars for 18.4 hours to make up for that, right? What we would do, in other words, is put 0 in for X, okay? 0 in for X, and I want to, so that would be 5Y greater than or equal to 92. How many hours we have to wash cars? Remember, that was Y, and we just did 92 divided by 5. Something bigger than or equal to 18.4, okay, but less than 20. So something between 18.4 and 20 hours. Anything in between there, 18.5 hours, 19.5, 20, okay? Those are the Y's that go with that. If you wash cars for 10 hours, okay, that's right here. If I wash cars for 10 hours, what range of times could you spend walking dogs? Well, looks like between, what, 6 and 10? That's how long I'd have to wash cars. If I'm going to wash cars for 10 hours, that puts me here. Then I notice the shaded region is in between where X is 6 and X is 10. So I'd have to make sure I walk dogs between 6 and 10 hours. That's how that graph is so helpful. Okay? All right. Can you guys try this one for me? Okay. Read through that and see what you think. I'm going to go ahead and read it. I'm going to pause myself for a second. You pause me and read it and see what you think about setting up this equation, these equations, okay? Again, I do have them graphed for you. It's very similar in that we have how many pounds we can do of paper products, etc., and then also plastic bottles and paper products, and also money, okay? We got the pounds, we got the money. So hopefully you got X plus Y has to be less than 10. They will remove up to 10. Okay, that's less than 10, not up to and equal to, but up to 10. So X plus Y has to be less than 10. 25 cents times the number of plastic bottles, pounds of plastic bottles, 75 cents for the number of pounds of plastic or paper products has to be less than or equal to $5. Okay? Less than or equal to $5. So here are the graphs. Okay, the less than 10 is right here. Everything underneath it we shaded. Also everything underneath this one. If you have 2 pounds of plastic to recycle, here we are with 2 pounds of plastic. Okay. What's the range of pounds of paper that you can recycle and still stay within budget? What's that look like between, now we're looking at, here's the 2 pounds. Now I'm looking here, between 6 and 8, it looks like. Oh, 0 to 6, I mean. Yeah, sorry. We're just looking at the pounds of paper. If you have 2 pounds of plastic to recycle, what's the range of pounds of paper you can recycle and still stay within budget? Okay, the dark shaded area is right here. So between 0 and 6. I was looking up here for a second. 0 to 6 pounds. It has to be in the doubly shaded region. Okay. All right, and then one more. Jason goes to the butcher shop to buy wings. He's letting that equal Y. Hot dogs, he's letting equal X. For Super Bowl Sunday party with his friends. Of course, the Steelers will be in that part in there. He can get wings for 50 cents each with the purchase of 2 dozen or more. And hot dogs for $1 each with the purchase of 10 or more. He budgeted $40 for food at the party. This time we have a system of 3 equations to model this situation. Think about that one for a minute. Okay, and they are graphed over here if that helps. Okay, pause me for a second and see what you get. Okay, so we have to buy up 10 or more hot dogs, and hot dogs was X. Okay, so that's where I got the X is greater than or equal to 10, which is right here, this line. We have to buy 2 dozen or more to get this 50 cents each of wings. Well, 2 dozen, that's 2 times 12, that's 24. So Y is greater than or equal to 24. So here's that line. Okay, greater than or equal to 10, greater than or equal to 24. And then the money is, it's $1 per hot dog, 1 times X, plus 50 cents per wing. And I can't go over 40 bucks. That's all I have for the party. Okay. If I rearrange this, I have 0.5y is less than or equal to negative x plus 40. Divide by 0.5, you get negative 2x plus 80. Now notice my x is going by 5s. My y's are going by 10s. So it looks like at first I'm down 1 over 1, down 1 over 1. But going down 1 is going down 10. And going over 1 is going over 5. Negative 10 divided by 5 is your negative 2. Okay, so that is a negative 2 slope. Here's my region, just in here. So if I buy 24 wings, exactly 24 wings, it looks like I can buy between 10 and what, maybe 26, I don't know, 27, 28. Let's figure that out without algebra. It's X, I'm going to put 24 in for Y, and I get 28, less than or equal to 28. Okay,